Conducting a root cause analysis and then implementing corrective and preventive measures are key components of a quality and food safety system. Though not specifically required in food regulations, a root cause analysis is a critical step in the corrective and preventive actions, a CAPA process. Corrective and preventive actions is a core requirement of the FDA's FSMA final rule for preventive controls. It involves taking immediate action to correct a detected problem, investigating its root cause, implementing changes to prevent recurrence, and verifying that these actions are effective. Corrective and preventive actions are essential for compliance with regulations, protecting consumers, and ensuring continuous improvement in food safety management systems. In food manufacturing, a root cause analysis, or RCA, is a systematic process for identifying the fundamental reasons behind food safety or quality failures, rather than just addressing symptoms. It involves a structured investigation to find the underlying causes, which can relate to equipment, personnel, processes, or materials, and then implementing effective corrective and preventive actions to mitigate the chance of recurrence. Tools like the 5 Whys technique and Fishbone diagrams are commonly used to uncover these root causes, fostering continuous improvement in food safety systems and a proactive approach to problem solving. Why is RCA important in food manufacturing? There are many reasons. Here are some examples. Prevents recurrence. By addressing root causes, businesses can stop the same problems from happening again. Improves product safety and quality. RCA helps identify and eliminate vulnerabilities that compromise product safety, authenticity, and quality. Reduces costs. It helps avoid expenses related to recalls, product waste, and damage to a company's reputation. Fosters continuous improvement. RCA creates a systems-based approach, allowing companies to anticipate and mitigate risks proactively. And ensures compliance. It supports adherence to food safety standards and audit requirements, such as those in SQF. The common steps in food manufacturing RCAs include: define the problem. Clearly describe the incident, nonconformance, or defect. Look for the who, what, where, when, why, and how related to the issue. Collect data. Gather all relevant information about the incident to understand what happened and the immediate causes. Analyze causes. Use RCA techniques to identify the underlying, fundamental causes of the problem. Implement corrective and preventive actions. Develop and implement solutions that address the root causes to prevent future occurrences. And review and monitor. Evaluate the effectiveness of the implemented actions and monitor the system for ongoing improvement. The common RCA tools and techniques typically used in the food industry are: 5 Whys. Repeatedly asking why to drill down to the fundamental cause of an issue. Fishbone diagram. A visual tool that categorizes potential causes to systematically identify contributing factors. Pareto analysis. Using the 80-20 rule to identify and prioritize the most significant causes impacting a problem. And the failure mode and effects analysis, or FMEA. A structured approach to identify potential failure points and their effects in a system. For complex problems, you may find it valuable to use multiple root cause tools to solve the issue. The 5 Whys technique is a root cause analysis tool that involves repeatedly asking why to a problem, typically about 5 times, to uncover its fundamental cause rather than just its symptoms. This systematic process helps prevent recurring mistakes, improves food safety, enhances compliance with standards like SQF, and builds consumer trust by addressing systemic issues rather than assigning blame. It is important to note that even though it is called the 5 Why technique, it may take less, but more often than not, it will take more iterations to reach the root cause. Here is how the 5 Whys process works. First, define the problem. Clearly state the specific issue that occurred. This is the most important step because if the problem is not properly defined, you may attempt to fix the wrong issue. The next step is to ask the first why question to determine the immediate reason for the problem. The why question is generated by taking the problem statement and turning it into a question of why it is happening. Then answer the question. Then ask why? Again, using the answer to the first why question. Repeat this process, continuing to ask why for several more rounds until you reach the true root cause. And the last step is to address the root cause. Once the root cause is identified, implement a targeted corrective action to prevent the problem from happening again. Here is an example. The problem statement is, a batch of gravy was rejected for having a high bacteria count. Then ask why. Number 1. Why did the gravy have a high bacteria count? The answer was determined to be, the gravy was not cooled quickly enough. This leads to why. Number 2. Why was the gravy not cooled quickly enough? The answer is, the cooling tunnel was operating below its design efficiency. Why 3. Why was the cooling tunnel not operating properly? Answer, the cooling unit's compressor was failing. Why 4. Why did the cooling unit's compressor fail? Answer, the compressor was not properly maintained as part of the preventive maintenance schedule. And why 5. Why was the compressor not properly maintained? And the answer and ultimately, the root cause is, the maintenance team lacked the necessary training and clear procedures for inspecting and replacing aging compressor components. There are several benefits for the 5 Whys system in the food business, including improved food safety, identifies weaknesses that could compromise safety, leading to fewer incidents and recalls, prevention of repeat mistakes, uncovers systemic issues rather than just addressing symptoms, preventing the same problems from recurring, enhanced compliance, helps meet regulatory and audit requirements by demonstrating a thorough approach to problem solving, better training, reveals gaps in training and procedures, leading to more effective team development, and increased consumer trust, demonstrates a commitment to quality and safety, strengthening brand reputation. A fishbone diagram, or commonly referred to as an Ishikawa diagram after its founder Karu Ishikawa, is a visual tool used to identify the root causes of a problem by categorizing potential causes under major headings like the 6 M's, which are man, machine, method, material, measurement, and mother nature or environment. By brainstorming and organizing potential factors that could lead to issues such as food safety violations, product defects, or production inefficiencies, food manufacturers can systematically analyze the problem and implement effective solutions for continuous improvement. So how is a fishbone diagram analysis performed? First, define the problem. Identify the specific issue or effect you want to analyze, such as poor product shelf life or contamination in the production line. The problem is then placed in the head of the fish. Draw the backbone. Draw a horizontal arrow pointing to the problem statement. Identify the cause categories, which are filled in as the ribs. Draw diagonal lines branching from the backbone. Use categories relevant to food manufacturing, such as the 6 M's, to organize your search for causes. They are manpower or people, which include issues with staff training, procedures, or human error. Machine-involved problems with equipment, machinery maintenance, or calibration. Method or process include inefficient processes, incorrect handling procedures, or flawed operational steps. Material can be issues with raw ingredients, packaging, or supply chain quality. Measurements are problems with inspection, testing, or data recording. And mother nature or environment include factors like temperature fluctuations, humidity, or sanitation issues. Then brainstorm the causes. Within each category, brainstorm all the potential factors that could contribute to the problem. The next step is analyze and prioritize. Use the diagram to identify relationships and prioritize potential causes for further investigation. Now it's time to determine the root causes by employing techniques like the 5 Whys to break down prioritized causes until you identify the true root cause of the problem. And lastly, take action. Develop and implement solutions to address the identified root causes, supporting a cycle of continuous quality improvement. The key benefits of using the fishbone diagram are: systematic analysis, provides a structured approach to problem solving. Root cause identification, helps uncover the underlying reasons for issues, not just symptoms. Enhanced brainstorming, encourages a cross-functional team to generate a comprehensive list of potential causes. And focus on quality, supports continuous improvement efforts in product safety, quality, and process efficiency. Pareto analysis, also known as the 80-20 rule, helps companies identify the vital few factors, 20%, that cause most of the problems or inefficiencies, referred to as the 80%. By focusing on these critical areas, such as specific production lines, key raw materials, or particular types of waste, manufacturers can significantly improve quality, reduce costs, and enhance operational efficiency, leading to better overall results. Here is how the Pareto analysis works. First, collect data. Gather data on production issues, such as defects, equipment downtime, or waste. Next, categorize data. Group the data by type, for example, different types of quality defects or sources of waste. Third, order the issues by impact. Rank the causes from highest to lowest based on their impact, such as the frequency of the problem or associated cost. Now you can create a Pareto chart. Visualize this data on a chart, with a vertical bar graph showing the most frequent or costly issues on the left and a cumulative percentage line. And then review the chart to identify the vital issues to solve. The chart will highlight a few major categories that contribute the most to the overall problem. The benefits of using a Pareto chart to conduct an analysis include efficient resource allocation. Directs resources and efforts toward areas that yield the greatest improvements. Improved decision-making. Provides a data-driven basis for making strategic decisions about problem solving. And increased productivity. By addressing the most impactful issues, companies can significantly boost their overall efficiency. Failure mode and effects analysis, or FMEA, is a proactive, systematic process for identifying potential failure modes in a product, process, or system, assessing their potential causes and consequences, and prioritizing them for mitigation to improve reliability and prevent harm. It involves analyzing a system, determining the severity of failures, their likelihood of occurrence, and the ability to detect them, often leading to a calculated risk priority number, or RPN, to focus on the most critical risks. The key steps to a failure mode and effects analysis are: 1. Identify failure modes. Determine all the ways a product, process, or system could potentially fail. A Pareto analysis can aid in this step to list and prioritize issues. 2. Determine potential causes. For each failure mode, identify the potential causes of that failure. Using a 5 why or Fishbone diagram may help through this step. 3. Assess severity, identified as S. Evaluate how serious the consequence of each failure would be on the system, product, or customer. 4. Estimate the chance of occurrence, identified as O. Gauge the likelihood or frequency of each potential failure mode occurring. And 5. Determine detectability, identified as D. Assess the probability that current controls or methods will detect the failure before it causes harm. Now, calculate the risk priority number by multiplying the scores for severity, occurrence, and detection to rank the identified failure modes. The formula is RPN equals S times O times D. So, if the severity is 6, the risk of occurrence is rated as a 4, and the chance of detection is a 2, then the RPN is 48. And then the last step is to prioritize and act. Use the calculated RPNs to prioritize which risks to address first, focusing efforts on the most critical areas with corrective actions. The key benefits of failure mode and effects analysis include: improve quality and reliability. By identifying potential failures early, FMEA allows for corrective actions, enhancing product and process reliability and quality. Reduce costs. FMEA minimizes costly issues, rework, warranty claims, and recalls by addressing potential failures during the initial design or development phase. Early risk identification. The method provides a structured way to pinpoint potential failure modes early, preventing costly late-stage changes to projects. Customer satisfaction. A higher quality product, resulting from FMEA, leads to greater customer satisfaction and a stronger brand reputation. Continuous improvement. FMEA is an ongoing process. It is regularly reviewed and updated, promoting a culture of continuous learning and process optimization. and knowledge management. The documentation created during FMEA serves as a valuable knowledge base for current and future projects, preventing the repetition of past failures. Once the root cause is determined, it is time to develop and implement a corrective and preventive action plan to fix the problem or problems. The corrective and preventive action process is a widely known system used to analyze potential food safety issues and protect businesses in the food industry. A corrective and preventive action, or CAPA system involves two different solutions with very different approaches, corrective and preventive methods. Uncertainties in a food business can always lead to risks and hazards. Risks can always arise regardless of how robust your food safety management system may be. The majority of food safety systems are built around the premise of preventing these risks from occurring through systematic planning. The corrective and preventive action process is a systematic tool used to collect and analyze information on potential problems and create appropriate corrective and preventive actions to prevent a recurrence. The main objectives of the CAPA process include the establishment of immediate corrective actions in case a problem occurs and a plan to determine the root cause of the problem while establishing ways to prevent it from happening again. The CAPA process involves two different methodologies. The corrective action process. This operation involves reactive procedures that aim to address the current nonconformity at hand. And the preventive action process. This proactive operation includes a deeper analysis of the root cause of the problem and helps eliminate the potential for the nonconformity to occur again. In some food safety systems, such as the HACCP and the Safe Quality Food Program, the CAPA process is mandatory. For HACCP, CAPA is part of the prerequisite programs and must follow a set of standard operating procedures. The successful establishment of a corrective and preventive action process in a food business can help improve the approach to food safety, therefore limiting the chances of causing foodborne illnesses and losses in profit. The CAPA process has many different interpretations, and the number of steps may vary depending on the complexity of the plan used by a company. Sub-steps can often be added to improve specificity. The Food and Drug Administration has released a series of steps used as CAPA procedures. Several different interpretations of this guide have been used in different food safety systems. According to the guidelines released by the FDA, the CAPA process involves the following steps. 1. Identification of appropriate action. Appropriate remedial actions mean choosing the correct solution to the problem, either corrective or preventive action activities. The parameters which will be used to arrive at whether the nonconformance will require corrective or preventive actions will come from the investigation process. 2. Verify and validate the effectiveness of the chosen action. At this point, your team must check whether the chosen solution worked and did not form any subsequent nonconformances. In addition to proper implementation, rigid monitoring of the action's results must be properly documented for analysis. 3. Implement changes. Once the testing stage for the preventive controls has been verified and approved, the changes must then be implemented to standardize the succeeding operations where the nonconformance is non-existent. 4. Disseminate information. The information regarding the nonconformance that occurred, the conducted analysis, and the implemented changes must then be communicated to the involved or affected operators and personnel. And 5. Submit management review and documentation. Documentation is an important component of the CAPA process. It is your proof that the system is robust and working, and it will be your mode of sharing the information with your whole team. The key components of a corrective and/or preventive action includes problem identification and root cause analysis. Clearly define the problem and thoroughly investigate its underlying causes to ensure the action addresses the real issue. SMART goals. Ensure the action is specific, measurable, achievable, relevant, and time-bound to enable effective implementation and evaluation. Clear action plan. Outline the exact steps to be taken, assign responsibilities and deadlines, and document all changes to processes, procedures, or equipment. Training and communication. Train affected staff on the new processes or procedures and communicate the actions taken to ensure everyone understands and adheres to them. Documentation. Create official documentation of the new policies, work instructions, or processes to ensure the changes are sustainable and can be audited. Verification and monitoring. Establish processes to monitor the effectiveness of the corrective action, review its impact, and make adjustments as needed. And stakeholder buy-in. Secure support from relevant stakeholders and ensure collaboration for successful implementation. So, a lot has been said about verification and validation, but you may ask how they work? Verification and validation must include the following elements. Data collection. Gather data, records, or observations to confirm the problem no longer exists or its occurrence has been significantly reduced. Monitoring. Continuously monitor relevant metrics or conduct regular audits over a specific timeframe to ensure the problem does not reappear. Scope review. Ensure the corrective action scope considers other relevant areas, products, or procedures to prevent reoccurrence elsewhere. Documentation. Record the entire process, including the problem, root cause analysis, actions taken, and verification findings, to create a reliable record for future audits and continuous improvement. And the purpose of verification and validation are: prevent recurrence. The primary goal is to ensure that nonconformities do not happen again. Ensure effectiveness. Confirm that the implemented solutions actually work and are not just a temporary fix. Achieve compliance. Meet the requirements of quality standards like ISO 9001 and regulations from bodies like the FDA. And drive continuous improvement. Identify areas for improvement within the quality management system. Understanding how to conduct and implement a root cause analysis and corrective and preventive measures are key components of a quality and food safety system. We hope you found this training valuable. Please click the subscribe button to access additional food sure training videos.